Hello, welcome to the Ponderings podcast. This is your host, Milo, and in this episode, I'm going to be talking about quantum entanglement and then comparing it to Whitehead's process philosophy. This is the third SpookyCast episode for the month of October, and you can listen to this podcast on most podcast streaming apps, and I also have a YouTube channel where I post each episode. We can use quantum entanglement to explain Whitehead's process metaphysics. And what I mean by metaphysics is the study of first principles of things. So it has to do with space, time, cause, substance, knowing, being. It's like a ground theory or a framework which encompasses a paradigm or a point of reference. It's a sort of a cosmology. It gives us a framework for how everything works and how it all fits together. So what is quantum entanglement? So when two objects are entangled, this means we can know a characteristic of one based on the characteristic of the other. So they lack independence. And when they interact, the interaction creates a correlation between them. So an example of this could be how molecules have subsystems of electrons and nuclei, and the electrons and nuclei have to move together because they're part of a larger system. So the electrons won't move independently from the bigger system, or even they have to move in conjunction with the other electrons and also orbit the nucleus, and then the atom also has to work in conjunction with the other atoms and whatever makes up the molecule as a whole, because they're part of that larger system. So we can start understanding quantum entanglement a little better by going over Niels Bohr, his principle of complementarity. So in this principle, objects have certain pairs of complementary properties which cannot be observed or measured at once. So a property that is not measured basically doesn't exist. The measurement is sort of that active process that alters the system being measured. And when you measure something, that's how you're able to decipher specific properties. So what do we mean by measurement? It's observation, pinpointing exact position or location. It's figuring out the direction of the spinning motion in a particle, being able to observe entanglement, coherence, things like that. So a good experiment to sort of illustrate the principle of complementarity is the wave-particle experiment, the double-slit experiment. So it's impossible to be a particle and a wave at the same time for an atom. The type of measurement determines which property is shown. In the double slit experiment, there was basically two holes made, and then they were observing to see whether they'd be a wave or a particle. And what they figured out is it depended on how they were measuring and what measuring apparatus they were using to measure. So when they measured for a wave, that's what they saw. But then when they measured for a particle, then they were able to figure out the exact location of these particles. So it's not that atoms are either a wave function or a particle, but rather it's how we're measuring it that determines that property, or that brings out that property in the atom. So some effects of wave and particle can be shown in one measurement. Complementarity occurs in pairs. The electron's position versus its momentum. Again, you can tell if you're measuring for the position, it's going to be hard to figure out its momentum, but if you're measuring for the speed or the momentum, then figuring out the position will be difficult. And these limitations in precision are quantified by Heisenberg's uncertainty principle and Planck's constant. So now let's go over the complementarity principle and the uncertainty principle of Heisenberg. So nature is indeterminate to some degree. All properties and actions in the physical world manifest themselves as non-deterministic. So this means that they cannot be exactly known, established, or defined precisely. So not all aspects of a system can be viewed simultaneously. Again, in the double-slit experiment, using one particular apparatus reveals to us the wave aspect of electrons. Using another apparatus reveals the particle aspect of an electron. It's the observer and the measuring apparatus that they're using that sort of determines what we're going to be looking at. Again, it's also like with when scientists are conducting any experiment, they're going to be looking at the experiment through their paradigm, through their theories, using specific machines and apparatuses that will sort of bias the properties that we're going to be looking at. And it's not their fault. I mean, we can't build a machine, at least not yet, that'll just be like show us the reality of everything, every property. Again, we're still going to be observing, and the observer is going to affect whatever they're observing. A sharp separation between the behavior of atomic objects and the interaction with the measuring apparatus is impossible. The observer, the measuring apparatus, the thing being measured are entangled in that specific action, and they affect one another. And Einstein, he called quantum entanglement spooky action at a distance. According to quantum theory, two entangled particles will move and exhibit the same properties as the other, even from a far distance. Quantum mechanics does away with the notion that physical systems have definite properties independent of whether those properties are measured. So the conclusions are, there are no independent properties. Relations give rise to properties. Nothing can exist independently. Let's sink that in. Relations give rise to properties. The observer, the measuring apparatus, the thing being measured gives that thing being measured its properties of whether it's a wave or whether it's a particle. How we're viewing things, us as a measuring apparatus, we affect the things that we are observing, and we give them properties based on what we're able to, or how we observe or measure things. And that's not an exact, correct interpretation. I'm just sort of trying to relate that back to how we observe things and how we sort of affect how we measure things or we observe things. So now I'm going to sort of talk about Whitehead and quantum entanglement and how it could be easier to understand Whitehead's process philosophy if we sort of take this entanglement approach and how relations give rise to properties, and that there's no independent properties. Nothing can exist independently. So in Whitehead's philosophy of organism, his process philosophy, he doesn't think that there are static substances. Everything that exists are called actual entities. And these actual entities are not beings or souls. They're just drops of experience, occasions of experience. A being is in the process of becoming. So if we're looking at a human, we're made up of experiences, and we're made up of occasions of experience, actual events. When we're moving into the next present moment, so when we're moving into the future, when we're taking our historical route with us, we're taking all of the actual events in our past, and this would include potentialities that we have in front of us, and also eternal objects. And what Whitehead means by eternal objects, he means past actual events, which are no longer actual. They're just potential. For Whitehead, he sees us as all experience is interrelated, interconnected, and it affects, just like quantum entanglement, it can affect obviously relevant things around it, relevant experiences, relevant processes of becoming, but it also can affect far away instances of becoming. So one thing about Whitehead's philosophy that's can be very impactful is this notion. It can make us think about our environment a little differently. We are part of the environment, and we affect it. We affect everything, and we're not insignificant. Like, when you look up into space and you see how small you are, you can start to think like, oh, like we're so insignificant, little tiny human ants, like running around. But we're not insignificant. Even ants are important in keeping the entire universe like together, if that makes sense. And obviously humans are not insignificant, especially looking at how our climate is changing and that we sort of are affecting that through our actions and sort of disdain or disregard for the environment and also the other creatures on this earth. So maybe our impact isn't immense when it comes to the entire universe, but our impact on this system, on the earth system, because we are subsystems of the earth, our impact is pretty great. And so is the impact of all other creatures and the atmosphere. It just, Whitehead's philosophy, I think, makes you think a little bit differently, or at least it makes me think a bit differently about impact and even just how important relationships are, and not just relationships like between humans, but just our relationships with other creatures, the atmosphere, objects. Relations are like sort of the essence of everything. For process philosophy, there is no substances, there's only relations. I am because of all the relationships between atoms, between the molecules, between the cells, the organs, the cells that make up the organs, and those specific systems, central nervous system, all these things are relations. But then I also am because of other multicellular systems, my parents, their parents, but then, they are because of an ecological system that keeps humans alive, that keeps creatures like able to live and like move. So relations are very important, and looking at yourself as a relation as well as being made of relations, and also you came to be because of other relations. So yeah, nothing can exist independently. So this episode was less about quantum, little more about just thinking about Whitehead and why his philosophy is something important to think about. I'm just learning about quantum, really, these past couple of weeks, and it's really interesting. So I'm not an expert when it comes to that, but it does help me understand Whitehead's philosophy a little better, and I hope that it helps you understand his philosophy a little better. But anyways, thank you for listening, and I hope you stay tuned.